Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shakila binti Bukhari. My matrix number is 33 DPE 90F 2055 from DPE 3. So I want to present about safety interlock system or known as SIS. So what is interlock system? An interlock can be defined as a device that prevents you from making an inappropriate maneuver or adjust the system to a safe state if you make an inappropriate maneuver. In the context of safety, interlocks can prevent a user from making unsafe actions or minimize the hazard of unsafe actions by rendering the machine in a safe condition when an unsafe maneuver occurs. For example, a guard may be interlocked to prevent machine operation when a guard is removed, or a control may be interlocked to make it non-operational if a dangerous condition will result. Safety interlocks may have additional or combined features to reduce hazards. So, the example of interlock is many product standards mandate interlocks in both industrial equipment and in everyday consumer products. Examples of consumer products incorporating interlocks are removal of a guard on a food processor prevents the operation of the motor and blade, thereby reducing the opportunity for spinning blade injury, which is example of guard. Second, removal of the filter access door on a forced air furnace prevents operation of the blower motor and possible contact with the blower blade and or combustion gas recirculation hazard, which is example of guard and secondary hazard of recirculation. Third, the gear shift selector on a car allows the engine to start in park position only, which prevents the operator from starting the engine in gear and the possible unexpected vehicle movement, which is control example. Fourth, the inability to open the door and close washer during the high-speed extraction cycle either prevents access to the spinning drum or stops the drum's rotation open door opening, which is example of either guard or control feature. So, SysLogic solver is control hardware for safety instrumented function should be separate from the control hardware used to regulate the process, if only for the simple reason that the SIF exists to bring the process to a safe state in the event of any unsafe condition arising, including dangerous failure of the basic regulatory controls. Next, if a single piece of control hardware serves the dual purposes of regulation and shutdown, a failure within that hardware resulting in loss of regulation, which is normal control, would not be protected because the safety function would be disabled by the same fault. Next, safety controls are usually discrete with regard to their output signals. When a process needs to be shut down for safety reasons, the steps to implement the shutdown often take the form of opening and closing certain valves fully rather than partially. This sort of all or nothing control action is more easily implemented in the form of discrete signals triggering solenoid valve or electric motor actuators. A digital controller specially designed for and text with the execution of safety instrumented function is usually called a logic solver, or sometimes a safety PLC is recognition of this discrete output nature. So in chemical industry, the nature of chemical plants is such that there has to be some order to things, else the end result will not be what is desired. Or worse, a very unsafe condition could exist. Thus, there are interlocks to help avoid these situations. Some interlocks could be as simple as a too high or low temperature. If, for example, a chemical reaction is only safe at a certain temperature, then the system may not allow the plant operator to start that process if the temperature is too high or too low. The same for pressure, flows, etc. Another example is a boiler. Every boiler should have an interlock that prevents it from being started if the water level is too low. Some gas furnaces have interlocks that prevented them from being started if there is not enough air, combustion air, or too much or too little gas, or if the purge sequence has not been completed. Example in chemical industry. Safety instrumented systems are most often used in process. Example, refineries, nuclear facilities to provide protection such as high fuel gas pressure initiates action to close the main fuel gas valve. Second, high reactor temperature initiates action to open cooling media valve. Third, high distillation column pressure initiates action to open a pressure vent valve. So next, what is a SCADA system? SCADA stands for Supervisory Control and Data Acquisition. It is a type of software application program for process control. SCADA is a central control system that consists of controllers, network interface, input or output, communication, equipment, and software. SCADA systems are used to monitor and control the equipment in the industrial process, which includes manufacturing, production, development, and fabrication. The infrastructural processes include gas and oil distribution, electrical power, water distribution. Public utilities include a bus traffic system takes the reading of the meters and checks the status of sensors in regular intervals so that it requires minimal interference of humans. The SCADA system allows operator to change the set point for the flow and enable alarm condition in case of loss of flow and high temperature, and the condition is displayed and recorded. The SCADA system monitors the overall performance of the loop. The SCADA system is a centralized system to communicate with both wired and wireless technology to plant device. The SCADA system controls can run completely all kinds of the industrial process. For example, if too much pressure is building up in a gas pipeline, the SCADA system can automatically open a release valve. So, what is SCADA function? Supervisory control and data acquisition is a system of software and hardware elements that allows industrial organization to first control industrial processes locally or at remote locations. Second, monitor, gather, and process real-time data. Third, directly interact with devices such as sensors, valves, pumps, motors, and more through human-machine interface software. Fourth, record events into a log file. So next, SCADA system working. The SCADA system performs the following functions. First, data acquisitions. Second, data communication. Third, information or data presentation. And last, monitoring or control. These functions are performed by sensors, RTUs, controllers, a communication network. The sensors are used to collect the important information and RTUs are used to send this information to the controller and display the status of the system. According to the status of the system, the user can give the command to other system components. This operation is done by the communication network. So the conclusion is safety interlock implementation in a complex control system can be difficult, although the framework may seem heavy-handed for the simple example presented here. The methods are expandable to systems of much greater complexity. The framework breaks down the approach to interlock development into a simple series of steps and asks the developer in true consideration of system components in a well-defined approach. By following the HMI example presented, the result will be a system that provides protection for system components with a best practice approach to the HMI that has a proven track record. That's all from me. Thank you.